Hi guys, it's Wednesday night and I'm making a video, the final two videos on pointers. There won't be a program specifically on pointers. There's no program like that. Other things we've did, like, I don't know, nested for loops or stuff. There's programs that was just strictly made for that. Pointers are used in support, and we will have some programs, and I will show you along the way how to incorporate them in your programs and why they're important in your programs. We're spending this week just kind of learning how to use them and what they are. We'd already used the addresses last semester a little bit and early this semester with some of the pass-in by reference. Now this week it's just been the nuts and bolts of pointers. So I got two last programs to show you for pointers. And then we're going to move on to our next subject, which is kind of we touched on it before, and that's structs, and that will be our next program is with structs. So first, I want to run through these two programs on pointers. All right, like it says up in the top, this program uses subscript notation with a pointer variable and pointer notation. I introduced that last time you saw on the Tuesday production day, that video. I just wanted to kind of reemphasize that. All right, I've got a constant num coins equals 5. And then I've made an array of doubles called coins, and I've made it the length of num coins, which is 5. So basically, it's a double array, okay, and it's 5 long, which you would guess by just looking at the contents I put in it. I wrote this inline and 0.05, 0.1, 0.25, 0.5, and 1.0. All right. You know that this has to be a double when you see these decimals like this. They can't be ints. All right. Next thing I'm going to do is I'm going to declare a pointer to a double. All right. And then I've got an int counter, just a normal int. All right. So the first thing I did was I made a double pointer, and I keep cringing at some of the names I do, and made the variable name double pointer. I should think these things through better. So it's a pointer to a double called double pointer. All right. The very first thing I'm going to do is I'm going to assign coins to double pointer. This means that this double pointer is going to point at the array coins. Okay. So, and just like I did last time, there's two ways of seeing out this information, or I shouldn't say seeing out, running through a for loop for these. All right. It's like I said up here at the top, subscript notation with a pointer variable and pointer notation with an array name. All right. So let's go through this. Here are the values. All right. Count 0, blah, blah, blah. You all know this. Then double pointer count. Let that sink in a second. Double pointer here, and you can see it highlight up here, is a pointer. All right. It is pointing to the array coins. Okay. And as I see these out, count, it is going to see out the things that are at the addresses, these 5 addresses right here. This double pointer is pointing to an array, and it's like an arrow. It's an arrow. Think of you can see my little cursor here flying around. It's an arrow pointing at this one. Then it's an arrow pointing at the second one, the third one, the fourth one, and the fifth one as it works through this for loop right here. All right. I could have just as easily did this. I could have put coins, all right, with this count. It would have been coins 0, coins 1, coins 2, coins 3, and it would seed out each one of these. This way, it's seeing out the double pointer because this is pointing at the coins, the coin array. All right, let's go on down to the next one. And this notation was the one I introduced last time. I'm teaching this, but guys, I have never used this in a program. I've never used this kind of notation. It's something that you all just have to know in case somebody else does it. And you need to know it for a test. All right. Same thing, for loop, the pointer coins, which is the array, plus count. And this asterisk means it's pointer. All right. Guys, you just have to know, and I think most of you, if I handed out a problem on a test, could reason. You'd see this coins, you go up here and see the coins array, you'd see this count, and you'd think, okay, it's just going to go through one at a time, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, I should say. I think you can reason this out in a test, just knowing that this asterisk means it's going to point to something. All right, just for completion, I'm going to run this program. And there you go. Both of those ways work identical. Nothing was changed in the coins array. The pointer value didn't change anything. It was just strictly a C out. The key things is to know that this double pointer works the same thing as saying coins, and to understand the nuts and bolts of working through an array like an array pointer. All right, let's move on to the next one. All right, this looks a lot the same, but it is different. This program uses the address of each element in the array. So we've got num coins, basically the same array. All right, I've got a double. I'm got the same double pointer, except this time I'm not pointing at anything. Right, and then I've got a count. I've got a counter. All right. For loop, it's going to go through each element of the array, or it's going to go through 5 times. I guess I'm jumping ahead about the array thing. All right. So this is going to use the address. And again, this might make your all's heads hurt, but kind of just look at this code for a few minutes and pay attention to what it sees out. All right. Get the address of the array element. So the address of coins.count, right? Double pointer is going to point at that. Double pointer is a pointer, and it's going to point at coins coins 0 to start out with. Does that make sense? This is the address of coins 0 on the first trip through the array, and double pointer is going to point at that. All right. So then it's going to see out what's at double pointer. So this is just another way of working through it. Then it's going to go through these each time. Count coins 1, the address, double pointer is going to point at it. And then you're going to see it out. And it's going to go through the whole array like that. Let that sink in. This is the pointer. Look up here, you can see it's a pointer. And it's going to point at this address. Not just the address of coins, it's going to point at the address, because you have to realize this whole thing isn't one big address. Each one of these items inside this array is a different address. Okay, so this double pointer is going to point to these one at a time and see them out. So pretty uneventful. The main thing is you understand what's being pointed at here. Okay, double pointer and the address. This line here is the key line. If you don't understand this, let's talk about it. it's pretty important you understand this going forward. Not going to be any pointers in this next program, but there's going to be pointers this semester, and you definitely need to understand this, especially for test. Okay. All right, that ends what we're going to do with pointers. This is good enough to where when we get the pointers, these I went through 8 different programs and just showed you how pointers are used in them. That's enough for you to get started in programs using pointers. Um, like I said, no specific program for pointers. They're just going to be embedded going forward inside of programs. This next one is sort of a review. At least I hope it's a review. I hope this doesn't look too um, I hope this doesn't. I hope this looks familiar. All right. So this is structs, and it's not only just structs; it's an array of structs, and that's important. Structs by themselves can work, but um, arrays of structs um, give you chances for large amounts of information. So here's a struct, right? Okay, struct is a reserved word. Okay, you start typing it. Start typing. I mean, you can't name anything a struct. It's. I mean, you can name stuff a struct, but struct is a reserved word inside of C++. I'm calling this struct pay info, and inside each one is the amount of hours somebody works, and it's an int, so you can't put. I mean, it's going to have to be whole hours, and double pay rate because it's a double. You want double because you're going to be working with like 0.23 and things like that. All right. So picture just right now, just picture the struct. It's like one picture a square. I'm not square, a rectangle with 2 things in it, ints and hours. All right. Next thing I'm going to do is I'm going to go down here. I'm going to declare a constant because I want an array of 3. All right. And this is important right here. Instead of like making an int array, I'm making a pay info array. I could have made it any kind of array, but I've made it a pay info array. So it's going to have an array of these 2 things in bundles. Think of a struct as a bundle. Okay, it's going to have 3 bundles of information in this array. There's no limit to how big you make this bundle, which I'm going to show you in a second on a program I worked on for schools. All right, now that I got that declared, I just int index, to work through as a counter. So for index equals 0, regular for loop here. I'm going to see out and get the hours for employee number 1, right? Then I'm also for employee, I got index plus 1. Remember, index is 0 to start out with. So for employee number 1, 2, and 3, I'm going to see in the amount of hours, and I'm going to see in the pay rate. And just a little extra down here, I go through this, and I'm going to figure the gross pay, right? I've got the fixed and the show point. Something you might want to be thinking about because you all probably will be using this. Fixed show point. This is definitely a reminder. Show point means it's going to always show the two digits past the decimal, so you won't have you'll have $22.31, and then on the next one, $22.40 instead of $22.22.4. It's going to always show up as 2 decimals past. I'm sorry, 2 digits past the decimal. So this stuff is just going to give you the pay. One of the things y'all want to remember when you're seeing out is this workers index. Okay, this is the array. The dot pay rate. Okay, remember the dot. Here's the dot hours. That's how you refer to items inside of the struct. All right. You're going to work through the array in the index or the counter, and dot hours, dot pay rate is always the naming convention when you're working with these things. All right, so I'm going to run this. Hours worked by employee one, 40, $10 an hour. Uh, Hours worked by employee number two, 35. He makes $15 an hour. Employee number three, he works 45. He makes $12 an hour. All right. Because of my set precision, everything you can see set precision and fixed. This comes out to even what it looks like. It looks like dollar amounts. So $400, 525, and 540. Each one of these are figured using a separate struct. It's an array of struct, 3 structs. All right. What I mentioned earlier was showing you a project that I worked with. This isn't you. The structs are made for dealing with large amounts of information. All right. 2 summers ago, actually, my final class for getting my certification to teach college was a research class. All right. It was I was working with actually is a friend of mine who took me on as an independent student so we could work on some stuff that we both enjoyed, and that's we were both big college football fans. We're always paying attention to the recruiting and just different teams and different players as they come out of high school and follow them through college. And we was wondering if we could write a program that could predict a player's success using the information available coming out of high school. I mean, could I write a program and say that, yeah, the chances of this guy making it to the pros is this, chances of them making it starting in college is this. So one of the first things I had to do was put together information, and it's large amounts of information. This was, I think, 2 weeks worth of work for me to put together. This is kind of ugly because it's cut and pasted out of a lot of different formats. This is 1,000 players from each year, the top 1,000 players per, um, I forget what source we used for that, 24/7 Sports, I believe. The top 1,000 players. So if you look through here, look at this 2009, you can see there's 1,000 players from that year, 1,000 players from 2010, all the way up to 2014. So 6 different years. We picked these years because these guys would have been graduating in 2015, 16, 17, 18, and the next year, 19. We wanted to see how many of them actually, made it all the way through college, how many of them graduated, how many of them went on to the pros, right? So you can see here, it's a lot of information. Right now, to start out with, we got 6,000, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. All right. So right now there's 6,000 each with 11 pieces of information. So there's 66,000 pieces of information in this program. If you're just curious, this is the year they graduated high school, their ranking, their name, their high school, the college that they picked, the position they're going to play. This is the height in inches. 75 equates to 6'3". This is weight, 226. This is the star rating they were given by a different magazine. This was the quantitative number that they were given by 24/7 Sports. This is the city they grew up in and the state. The reason I'm showing you all this is this actually even grew to more information. These we put into formulas and things that we calculated. This 11 grew into something like 20 different attributes per struct. This was going to be 6,000 structs long, and I think it was either 18 or 20 attributes and different numbers and things in it. Right? The programs that I wrote would go through and do things to each struct one at a time. And it's just absolutely amazing how fast a computer is. 6,000 structs, even like it is now, just the 66,000 pieces of information, it'll bust through and it's so quick. I mean, it's like less than a second. That's why we do computer programming. I mean, I know a lot of people thinks it's for games and graphics, but computers really hit the old information highway for how it actually handled information. So I'm really just showing you this to show you that I was going to bring up the code, but it's in Java, and I thought, wow, some of it you'd look because of the commonality between C languages, between C++ and Java, you'd notice little things, but I thought it'd be kind of confusing. So I'm not showing you the code for that. I might actually write the code in C++ just to show you what this does. But what this does, this will put all this information for Matt Barkley. Some of you might remember the name. I don't think he's in the pros any longer. All this goes into one struct. And inside the struct, this will be called the year, ranking, name, high school, college, position, height, weight, ranking. Um, I forget what we called this, city, state. So all of those are variables inside of a struct. And like I said, there's 6,000 structs. And then you can go through and do anything you want with this information. It's really, once you get a sheet like this formatted, I mean, nobody in the world would go type this into a program all the time. Like I said, it took me, I think, several weeks to get all this information composed to actually then start to run and stuff. Once you get the information and can start running these programs, it's so quick. You guys know how to do things like comparison operators and things like this. Once you get this to where it puts all these into a struct, there's no end to the amount of things you can do with this information. All right, that's just a long way of showing you what you can do. And this is in Notepad. This isn't something that you've used before. I think I initially had it in a different kind of program. I mean, I'm sorry, a different kind of text editor. But Notepad works better with Java, and it works good. It works well with C++ also. All right. So that's all I've got. I just wanted you to see this because your next program will be working with a large amount of data. Um, and that's coming up probably either Friday, probably introduce it on Friday, and it's going to be due sometime later next week. I'm just spitballing here because I really haven't written down when it's going to be due. But you're going to be dealing with a lot of data, and you're going to be putting into structs and actually crunching this numbers. You're reading it from a file and doing some work on it. All right, guys, have a good production day, and I will see you in class on Friday.